My name is Ben Ruley. I'm a GIS and IT specialist with the Stearns County Conservation District. I've been working here for over 14 years now in this role. Do a lot of mapping work, database, IT support for our local office staff. There's a lot of different modeling tools out there, all different levels depending on what you're trying to accomplish. They take different amounts of time, they take different amount of money, depending on how fine or coarse of a tool that you're looking for. In this case, we use the ACPF, the Agricultural Conservation Planning Framework GIS suite of tools that was developed through the Ag Research Center. One, it's set up to run at a Huck 12 level, which is the scale that we are working at for this effort. Two, it's something that can be run by really anybody with, I'd say, moderate GIS experience. It's nothing that you have to be a modeling expert to understand. And you just kind of work through the tools in the order that they were established. There's really good documentation to walk you through that. And the primary thing you end up with is a data layer of the field, so field scale. And within your watershed, these tools will kind of rank those for the fields that have the highest potential for erosion within your watershed that you're focusing on, down to the ones that have kind of the lowest potential for erosion to be occurring based on your elevation data and your terrain, your slopes, your soils, and then your land use. Now, it does not give you reduction numbers like you might with some higher end models that are actually calculating phosphorus loads and sediment and nitrogen loads and things like that. So you're not getting that level of detail with the ACPF tools, but it helps you focus down on which fields and which farmers you would want to reach out to first that are most likely to possibly be experiencing, erosion in their fields. Again, based on all those terrain attributes that I mentioned. In order for these tools to be able to kind of predict these things accurately and where erosion may be occurring, you need to make sure that the tool knows the way that the water is moving through the landscape. Sounds kind of complicated, but again, it's just a toolbox. There's also a secondary layer, it's related to that, which not only does it consider whether or not this field has the potential to erode and have sediment and nutrients coming off the fields, but also is that load actually getting to receiving waters, getting to open water channels and basins. So that's why you need an accurate stream layer. With those data sets, now instead of having to look at every parcel, we can start by working at the ones that have the highest potential. And as you kind of work through those, looking at aerials and making notes and kind of creating a database of sites that we may be able to assist in, you're going to hit a certain point where you're just not going to be seeing a return on investment anymore. Maybe the first 50 or 60 fields you looked at with that high potential, I would say realistically, out of those 60, you might flag 20 of them. And a little work on the front end using something like ACPF or other modeling data, if it's available, can really cut down the amount of time you need to do desktop research or do drive-bys out in the field to identify sites that we may be able to help a landowner.